Hi guys, since there's been some interest in using DC motors to control a solar tracker, I thought I'd post a little update on where I'm up to on this project. Okay, so this is actually the electronics side, minus the compass and the GPS, which I've dealt with separately. So we can see here I have an Arduino. I've had to use an Arduino Mega here because I need the extra interrupts to be able to read from the limit switches and from the Hall sensors at the same time. This is the Pololu motor control, which I've posted on before. On the breadboard here I have the motor read circuit, which I've posted some schematics up of. I've had to make some small modifications to it just to regulate the voltage, as I was having some slight problems with the stability of that circuit. And then this is all just connected up to a car battery at the moment. If we follow the wires, we can see the actual Oyster unit, which is the unit we're going to be using to do our solar tracking. Okay, just to give you some idea how this unit actually works, we attach this aluminium arm, which is quite long, to this aluminium block that you can see in front of us. And the aluminium block can rotate to move this arm horizontally like this, or vertically like this. And on the back of this arm we will mount a solar panel so that we can actually track the sun. So rather than focus on this arm, we'll just focus back on the Oyster unit. We just want to control this aluminium block here to get horizontal movement. And then to get vertical movement, we can see there's a worm drive arrangement engaged with this gear, and then this is able to move this arm round like this, and since the arm attaches here, it will also lift up and down like this to give us pitch. At the moment you can probably see there's a limit switch here which is just dangling free. That should be attached on the side of this aluminium block here, so that this arm will press down on the limit switch once we've returned to the home position, and that indicates to the Arduino that the arm is laying flat along the unit like this and isn't up in the air. And that's important because we want to mount this whole unit on top of a motorhome, and we want to make sure that when we tell it to return home, it really does definitely go into the position with the least wind resistance, so that the vehicle can drive this way and the air will just move over this unit like so. Just to give you some idea of what's inside this unit, I flipped it over and we can see inside there are two DC motors connected to gearboxes, and they drive these cogs which allow the unit to move. And on this cog you can see there's a peg which is closing this limit switch here, and that's telling me that this unit is in the horizontal home position at the moment. The other switch that I mentioned previously would tell me that I'm in the vertical home position. All of these are just run directly out of the box and to my electronics there. Now the important thing to notice about these motors, there are actually 4 wires coming out. There are 2 wires here which just power the DC motor, and then there are 2 wires here which are actually the inbuilt Hall sensors inside these motors, and that's really important for us to be able to read exactly where we're pointing. I'll show this unit in action in a second, but first I'll just basically describe how it works. We decide that we want to move some angle, so the Arduino will decide that, and it will tell the motor driver to start moving the motors. Now obviously this block will start moving, and the motor Hall sensor will send pulses on the Hall wires, which are connected to this motor read circuit here, which is connected to an interrupt on the Arduino. Now the Arduino will simply count the pulses, and when it's reached the correct number of pulses for the movement we wanted, it will tell the motor driver to start moving the motors. If we want to return to the home position, we just count down those pulses, so we just simply reverse the direction of the motors and count the same number of pulses. Over the course of a day, I would expect for a few movements you might start to lose accuracy if you miss any of these pulses, which can sometimes happen. So we would expect that perhaps there's 1 or 2 degree drift The important thing is we have these limit switches, this will be attached here, and we have the one underneath that is attached. And that allows us to recalibrate the position and make sure that at the end of each day we're back in the home position, so that the errors don't add up too much only during the day. I'm now going to provide the unit with some power. The program's already loaded onto the Arduino, but I'm going to use a USB cable and a computer to provide the power. What's going to happen is this block will move 200 pulses, then it will move back, and finally it will recalibrate by moving itself very slowly back to the position it's currently in and detecting when it hits the limit switch inside. Okay, so we're connected to power now. I've built a small delay. There's the 200 pulses. Now it's going to move back. And now finally it's going to move a little bit further back and then recalibrate itself. So you can hear that there was a switch clicked, and now it's starting to recalibrate itself vertically, very, very slowly. But since this limit switch isn't in the place it should be, which is here, it's never going to hit this switch. So I'm just going to stop it right now.